Welcome to Hartman Math. This is lesson 3.2, Building Polynomials, part 1. We'll see if there's a part 2 coming up. Example number 1, we have a polynomial function written in factored form. Remember that from Unit 2. Just back in Unit 2, there were only 2 factors. Now we can extend and maybe have more factors. This time we have 3 factors. And it says find the x-intercepts and the y-intercept of our function p of x. So the way that we find the x-intercepts is the same way that we did back in factored form for quadratic functions, is we just take each of the functions, the factors of the function, set them equal to 0, and solve for x. It was a little bit easier sometimes. It's easy if they start with x. We kind of use that think opposite technique. We would subtract 2 both sides, x equals -2. Can't really do that here with a coefficient in front. So maybe we add a 2x to both sides and then divide by 2 and then add 3. So those values for x lead to x-intercepts. The y value was 0, x value is -2. -2, 0, 1/2, 0, 3, 0. Y-intercept. Same as always. If we don't see it, and we don't see it, we should substitute 0 in for x. So p of 0 equals, replace all the x's with 0. We can type this into a calculator. This times this times this. Pause here if you need to. When we type that into a calculator, we get -6. So we've got a y-intercept of 0, -6. We're going to see how these things help us with our graph. So part B, what happens in the intervals, we're going to look at this on a number line. We've already got our points plotted here, our x-intercepts, our y-intercept. Those are going to help. We're going to see what happens in the interval. We're going to create a sign chart. That's going to be a technique. So what we're going to do, calculators at the ready, we're going to pick first, as we've got marks on all of our x-intercepts. So if this is not set up for you, go back to our x values. That's where we're putting marks. And pick a number left of -2 on the number line, like -5. Plug in -5 there, multiply it out. What we care about, not so much as the value, is whether it's positive or negative. So I said sign chart, positives and negatives. So what kind of a number do you get if you plug in -5 there and there and there, and you carefully evaluate with the calculator? Pause here if you need to. You should get a positive number. Then let's pick a number between -2 and 1/2. I think we already did that actually. Earlier we plugged in 0. 0 fits in there. We got -6. That's a negative. And the positive part of the sign chart means that we are above the x-axis, left of -2. So above until we get to -2. Then we plug in 0, we get -6, so that's negative. So between -2 and the next x-intercept and passing through here, we are below. So here to here, we are below. How about 1/2 to 3? What can we pick? Kind of like 1. Plug in a 1, plug in a 1, plug in a 1. Use your calculator. Pause here if you need to. A positive number. So between these x-intercepts, we should be above somehow. So above, and then we're going to have to come back to it. And then lastly, what about past 3? Like 4. We could pick 4. That's to the right here. Pick 4, plug in a 4, plug in a 4, plug in a 4. Again, some calculator time. Pause here if you need to. Should get a negative number. So negative means past 3 we are below, and it's going to head off here, head off there. So we graphed the cubic function. We graphed p of x. How do we know it's cubic? We'll get to that in a moment. What is the end behavior as x approaches infinity? So as we go right on the graph, right, where are we heading? We're heading down forever. As x approaches negative infinity, as we go left on the graph, we are ultimately heading towards positive infinity. What is the degree of p of x? Okay, well, cubic should tell us something, but what is the degree of p of x? What would happen if we multiplied out all of the x's? X times negative 2x, that's negative 2x squared, times another x, negative 2x to the third. The degree is the highest exponent in the problem. So if we multiply an x and an x and an x and get x to the third, that tells us that our degree is 3. And that's what defines a cubic function, a function of degree 3. So highest exponent in our x's as a polynomial being 3. Let's look at existing graph and then see if we can kind of pull it apart, come up with the function that generated that graph. What are the 3 factors? So again, kind of think back towards Unit 2 where we saw here and here as far as x-intercepts, we want to work that backwards. So in terms of what's in the parentheses with an x that generates this. So remember, the form was x minus the number. X minus the number. X minus the number. And that generated us to think opposite. So x minus negative 3 becomes, well, minus minus becomes plus. So that's x plus 3. What about this one? X plus 1. What about this one? X minus 1. Those are our factors. Now write it as a polynomial. That should be pretty easy. Remove the commas. Q of x equals this times this times this. And there's our polynomial function. One thing we really need to watch out for, though, is in generating, make sure these work out. We might need to throw in an a value to make it happen. We'll see what happens here with our x-intercepts and so on. So the x-intercept we actually can see from the graph, so we can list those. The y-intercept we see from the graph, we can list that. Let's just double check. If we plug in a 0, do we get the negative 3? Because if not, we might need to have a multiplier here, an a value, to make it happen. But I think we do. So we get the 0 comma negative 3, which meant this was good. And how about our end behavior? As x approaches infinity, go right. We're going up. As we go left, we ultimately end up going down forever towards negative infinity. Let's look at one more example where we kind of repeat our process and we look at the sign chart. We've got r of x, find the x-intercepts and the y-intercepts. Once again, for the x-intercepts, set the factors, since we're in factored form, set them equal to 0, solve for x. So our x-intercepts are negative 2 comma 0, 1 comma 0. Y-intercept. Let's plug in 0 for the x, so r of 0 equals, make sure we do the exponent here on your calculator, type it in as you see it, pause here if you need to. You should get positive 2. So 0 comma 2. Let's look at generating that sign chart. So on the number line, make marks where we have zeros of the function, x-intercepts of the graph, which we've shown here. We also plotted the y-intercept. So now, again, let's pick a number left of negative 2 on the number line, like negative 4. Plug it in, negative 4, negative 4. Make sure we're doing this exactly as we see it there. And we're going to get a negative number. So in terms of the graph, we'll come back to that in a moment. So -2 to +1. Oh, we already did that. Pick 0. We got 2. That's a positive number. That's positive. And then let's try something out here like 3. Plug in a 3. Plug in a 3. We also get a positive number. So let's see what does that look like for our graph. So left of -2, we start out below. Left of, we start out low. And then between -2 and 1, we are above and pass through our y-intercept. Okay? But here's what happens is when we hit at 1, beyond there, we don't want to go below because this says that we want to stay above. So what has to happen here is stay curved, stay rounded, as it comes and it bounces off of the x-intercept at 1, 0. Because we went from positive to positive. We were above and stayed above, but just grazed the x-intercept right there. So we call that a bounce right there. So we have graphed the cubic function. We were below, above, above to match our sign chart. Now what's our end behavior? As x goes to the right, our function goes up. As x goes to the left, function goes down. What's the degree? Again, if we were to multiply it all out, we'd have to square that x. So x squared times another x makes x to the 3rd power. So the degree is 3. That's it for today. I'll see you next time.